Hello, good morning students. Myself Power MS from KJ Somaya College, Kopargaon. Today we are going to discuss our next rearrangement, that is a Favorski rearrangement. See, hereby I have to discuss the some rearrangement in previous lecture. So today's lecture we are discuss the next rearrangement, that is a Favorski rearrangement. So Favorski rearrangement is a electron-rich carbon atom rearrangement. So rearrangement takes place in electron-rich carbon. So we have to discuss here introduction related to the Favorski rearrangement. Suppose we have to discuss here the outline of Favorski rearrangement. Suppose in Favorski rearrangement we have to take alpha halo ketone or just related idea about the what is Favorski rearrangement. So in Favorski rearrangement we have to take the starting compound, that is a alpha haloketone. So alpha haloketone reacts with base. So any compound reacts with base, formation of the simply carbanion. So formation of the carbanion on starting compound, then carbanium which is form, then in next step the reaction mechanism followed by SN2 pathway or SN2 mechanism. So carbanium reacts as way, that is a SN2 mechanism, then formation of cyclopropane ring. When carbanium reacts or carbanium undergoes SN2 reaction mechanism, formation of the cyclopropane ring. So cyclopropane ring formation, then in next step ring opening takes place. So cyclopropane ring opening takes place, formation of the ester or acid. So it is depend on the which type of base we have to use, and then formation of the ester or acid. So ring opening takes place in the solvation or in presence of solvent, that is a EH plus. Then ring opening takes place and we have to get your final product, that is a ester or acid. So ester or acid, it depends on your nature of base. So this is the outline or related to the Favorski rearrangement. So you know idea about the what is Favorski rearrangement. Alpha haloketone reacts with base, then formation of the carbanion, then carbanion undergoes easily SN2 reaction mechanism pathway and formation of the cyclopropane ring. Then this ring can be open in the presence of solvent, so formation of the ester or acid. So next we have to discuss here statement of Favorski rearrangement. So the base cat statement, the both the base catalyze reaction of alpha haloketone, which is formed or gives ester or acid, which gives formation of which gives formation of carbanion. When this carbanion undergoes formation of carbanion, which is undergoes ESN2 reaction mechanism, reaction mechanism, formation of cyclopropane ring intermediate cyclopropane ring intermediate. Then in final step solvation takes place. In final step, in presence of solvent, presence of solvent, formation of ester or acid, that is your final product. So this is the statement of Favorski rearrangement. So last we have to see here formation of ester or acid. So this formation of ester or acid depends on the nature of base. So the next point which is important, when we have to use alkoxide formation of which is formation of ester. Then we have to use when we have to use hydroxide or OH minus formation of which product will be formed, any any intermediate reacts with the hydroxide or OH minus, easily formation of the acid. So understand, we have to use base alkoxide formation of the ester, and simply we have to use the hydroxide or OH minus, then we will be form acid as your final product. So formation of the ester or acid depends on your nature of the base. Understand? Okay. In next step we have to discuss the detailed mechanism of Favorski rearrangement. Rewrite here. So general reaction of Favorski rearrangement, CS3 C double bond O CS2Cl, that is your alpha halo ketone, reacts with any base. Sorry, we have to take here C2H5O minus, and then solvent formation of the ester, because we have to take here alkoxide. So this is your final product, that is a ester, and this is your alpha haloketone. So this is the general reaction mechanism of Favorski rearrangement. And next, let us we have to discuss the mechanism of alpha haloketone. We have to take here first of all alpha haloketone, that is a CS3 C double bond O CS2Cl. This is alpha or this is alpha. Okay, this is this carbon also alpha, this carbon also alpha. Okay, we have to take alpha haloketone. So this is alpha haloketone. First of all reacts with base. We have to take here base OC2H5, that is your alkoxide OR minus. Here the function of base, that is abstract the proton. So here presence of the CH2, we have to write this CH3 in the form of CH2 and H. So this base can abstract this proton, this bond shifts on this carbon. So in next step, formation of here CH2 minus C double bond O CH2 Cl. In first step, simply ethoxide can be abstract this proton, formation of the carbanion. Here formation of the carbanion. In next step, here presence of CH2 and here halogen. So we write negative charge here. So this carbanion attack on this carbon, at that time this Cl can be removed, minus Cl. So this addition of carbanion takes place as 1,3 elimination. 1,3 elimination. How? 1, 2 and 3. So this carbon attack on this carbon which is attached to the halogen. So this position is 3 and this position is 1. So eliminate the Cl minus. So mechanism is called as the 1,3 elimination. Okay. So bond between this carbon and this CH2. Okay. So we have to get here CH2 CH2. So bond between this carbon. So here this carbonyl as it is. Okay. So CH2 CH2, here formation of the cyclopropane ring. Minus Cl can be depleted by using the 1,3 elimination. So this intermediate can be formed. This is the cyclopropane ring. The cyclopropane ring will be obtained by using ESN2 mechanism. Here formation of the ESN2 mechanism way. So formation of cyclopropane ring. So this cyclopropane ring which is very unstable, because of this is the 3-member ring. Why it is very unstable? More unstable intermediate can be formed. The cyclopropane ring which is more unstable species, because what? Because of this is 3-member ring. In 3-member ring, angle strain which is also the present. Here presence of sp2 hybridized carbon. This carbonyl carbon is sp2 hybridized. So again this is the 3-member ring. Angle strain is 120 to 60, then 60 to 30. So angle strain very increases due to the 3-member ring. This is more unstable species. Here presence of the sp2 carbon atom. So this cyclopropane intermediate which is very unstable species. So this undergoes in next step. Again we have to use the base O C2H5. So this negative charge attack on this carbonyl carbon, because of this carbonyl carbon which is electrophilic in nature. So negative charge, this base attack on this carbon, because of this is a more unstable species, because of this is the cyclopropane due to what? Angle strain and presence of the sp2 carbon. So formation of next step, the CH2 as it is. Here formation of O minus and here addition of ethoxide O C2H5. This intermediate also form which is also the unstable. Here also the 3-member ring, but this carbon is sp3 carbon. So the sp3 carbon again undergoes the reaction further carried out. So here presence of the enolate ion. So this O minus revert back. So here formation of the carbon oxygen double bond. At that time this bond can be break up and shifts to the CH2. So formation of here, see here, this CH2 as it is. This carbon carries negative charge. Again this carbon attached to this carbonyl, here formation of the carbonyl and here O C2H5. So formation of this intermediate. See here, this negative charge revert back. Here formation of the carbon oxygen double bond. At that time this bond can be break up. or this bond shifts on this carbon. So here formation of the carbanion. Then see here OC2H5 you attach this carbon. See here, then here formation of the carbonyl. This CH2 as it is, this CH2 as it is, this CH2 carries negative charge. Because of this carbon carbon bond can be break, this carbon and this carbon cyclopropane ring can be open. Here ring opening takes place. See here, so in next step we have to use solvent. In solvation process, that is a H plus, formation of your final product, that is a CS3 CS2 C double bond O C2H5. This is your final product. The name of that product is ester. So this all about the mechanism of Favorski rearrangement. We have to discuss here detailed mechanism of Favorski rearrangement. See here again, alpha haloketone reacts with any base. So base which abstract the proton from this center. So formation of the again carbanion. So carbanion undergoes the SN2 reaction mechanism, formation of the cyclopropane ring by using 1,3 elimination. Simply formation of the cyclopropane ring. This intermediate which is very unstable. Why? Because of here presence of the sp2 carbon, and this 3-member ring which is very unstable due to what? Angle strain, presence of the angle strain. In next step it undergoes again reacts with the base, formation of this again intermediate, but here formation of the again 3-member ring, but this carbon is sp3 carbon and this carbon is sp2 carbon. So only tautomerism takes place, this enolate ion reverts back. At that time this ring opening takes place. In this step ring opening takes place from this side. So formation of the negative charge over this carbon atom. Again in presence of the solvent, solvation takes place. We have to get the final product, that is a ester. So all about this Favorski rearrangement. The remaining part of our rearrangement chapter we have to discuss in next lecture. Okay, thank you very much.